Okay, yeah, we are recording right now. Okay, so how's it going? Today is sort of my last workshop, yeah, meaning that we have a lot to cover today because I'm trying to finalize 2 different workshops today. Yeah, so we can make it happen. Great, let me share my screen. Okay, little adjust my Windows a little bit. Give me a sec. Here, chatting here. Okay. Great. Today we have 2 materials, as I said. One is the pipeline for data and geometry for visualization. And then the last material that we want to visit is the digital mapping using ArcGIS JSAPI things. Correct. So, first of all, as we did, we have a research overview and then some lecture things for the MVP pattern and some programming pattern for the CAD system and in action for the visualization. And then we have a set of the tutorials, some exercises, and then some additional materials there. Okay, great. So let me jump in a little bit. So this is one of my work to create a sort of, environment which is mimicking our complex system. So in this project, what I want to do is, there's a multiple environment. So in that environment, there's some a chain relationship between objects in that world. So for example, we have a tree here, right? So basically cloud produces the water as a rain, yeah? And then the individual tree can consume the rain, and then it meet a certain amount of level of water, and then it creates its own family around there. And then we can extract the tree from the ground, it becomes timber, and then we can move timber to factory to create the money. And at the same time, they produce, the carbon dioxide, and then it basically trigger, some natural disaster. It's like a chain effect. So, what I'm trying to say is, yesterday we made several class and objects, and then we know how to decompose the level of the execution, like a visualization level for the render, with some algorithm part for the the processing. Let's say the update or analyze their geometrical information during the loop, yeah, things like that. So in this level, actually, the most important thing is that you need to basically orchestrate all different types of geometry at once. So it's really hard to, yes, sometimes it looks really hard, but as I said, we can decompose the complexity in the small level that we can manage. Yeah. So today we're gonna learn how to do this anyhow. Basically computer aided design, CAD is a very well defined area. It has been a long time, right? And particularly, I want to looking at the CAD, with the perspective of the interaction things. So this is the sort of very old CAD system developed by Lincoln Lab. So they talks about it's very old, right? It talks about sort of an interaction with the sketchpad here. So there's all sort of mathematical, the geometric computation behind the scene, and then it has some, pipeline for the visualization and interaction based on your move with the sketchpad. It keep, interact and then visualize the data on the real time. So I think from that time, this day, 2020, yeah, this is 3ds Max, which is one of the, let's say very complicated CAD software for visualization and modeling for not only for architectural design, but also game industry or some, film and so on and so forth. As you can see, there's a crazy, button and, UI. I mean, UI and layers tool, selection tool, and rendering, and also you can pop up some menu by clicking some, mouse button with some shortcuts, so which is very crazy. So I think what I'm trying to say is we're gonna build this kind of interface to tweak our ecosystem. So yeah, I mean, SuggestMax is a very well-defined CAD software and Maya, things like that, because it has been developed for a long time. It received a lot of feedback about the users' use cases, I guess. So it has a very its own strategy to spread out and categorize the individual menus. Actually has its own city engine, which is located in the Europe. I couldn't remember the city, but the Ashley has some VR sort of interface. Yeah, we can not only visualizing the urban data, but also you can interact, you can zoom in and out, inspect some data. I mean, it looks very straightforward, right? But however, as I said, there's a lot of complicated things happening behind the scene. So we're gonna talk about multiple types of layer to control the complexity. Yeah. So we can move to here. So we reach one slide here, right? So we have been seeing multiple types of CAD system. The CAD system, all CAD systems actually support interaction, because without interaction, the CAD is become useless, right? So you want to interact, you want to apply some action to that environment, like click or move or draw, you know what I mean, right? So this is all about the interaction. So once you give some interaction, some command to the CAD system, and then we expect some feedback as a visual language, yeah? But inside of the program, there's a very clear, straightforward way. The first one is the input, received from the interaction, and then you need to compute, correct? And then at the end of the computation, you want to visualize on the screen so that the user can receive the feedback from their interactions, okay? Let me decompose a little more deeper. So here, application, yeah, the level of knowledge required. What I'm trying to say is that on the surface level, yeah, we have some, human-computer interactions, which is also one of the domain to dealing with the interface and some, user experience things. So on the first level, we have a command or UI controller or action sequences, right? This is all about sort of a surface, like a process, right? User can see, yeah? And then we receive these action sequences and then it basically trigger some particular algorithm, right? So for example, the algorithm is a sort of little high level algorithm, particularly for parametric design process or agent basis. So basically we have a set of cooking recipes there. And then the UI is trigger some action sequences based on their recipe, yeah? So in that area, in that zone, I feel like the most important thing is then let's say design experience. The domain knowledge is really important. So what I'm saying is this is the place where you can bring your experience in design practice. It has nothing to do with the computation, I think. And then go down one more level deeper. So we are encounter like an analytical geometry. Sometimes we call it computational geometry because we wanted to tweak the geometry by the number or some computation, right? So in this case, the knowledge required is that you need to understand the coordinate system, like a linear 1, 2, 3 space, which is Cartesian coordinate. Or we need to strong understanding about the vector and geometry and mesh, what is connectivity, how we compose or decompose mesh as a point or edge or polygon, things like that. So this is the more about computational geometry things. And then we can go down one more level right here. So now we are reached sort of a bottom level of the application. All the way down, there's some graphics library that hardcore engineer people have been developed so such as OpenGL, WebGL, DirectX, HTML, Canvas. These are provided us with very low-level API which directly talk GPU. Okay, so in that area, so computer science knowledge is required. So, for example, like how to create the class, yeah, how we designate the memory allocation, right? Also, how we create the thousands of the vertices on the fly, yeah. I mean, it has nothing to do with the design practice. It has nothing to do with the computation geometry. It's more about like understanding the computer system to maximize the performance. So this is sort of my understanding of the developing some of like a software, which I said, which software is not just software. Software is basically packaging our knowledge and technology in a way as like a mobile phone, So here, the developer for graphics, sort of, for example, like there's some computer science people specializing in graphics program. They're usually focusing on that area. Actually, you know what? The interesting point I found is that they have no idea about design experience and algorithm part. Basically, they are not interested in. They're really focusing on that kind of area, like let's say backend of the CAD software. Okay. At the same time, I also found one interesting aspect, as opposed to the other something as I said. The designer has no idea about the backend. So there's some it's really bit hard to accord, make them together. So actually, yeah. Anyhow, yeah. I mean, I'm trying to make two different. I'm trying to make a bridge between two areas. So this is my sort of uniqueness I'm trying to develop right now. So here, the other way around is like it talks about like technology. Previously, we talked about the knowledge, the depth of knowledge. But here we talk about like a sort of technology things. So all the way down, as I said, we have some of the low-level core library, and then the graphics, the computer science people, they basically develop some very basic classes, just we did yesterday. And then they create the API that user can access, yeah, such as like a C#, Rhino Python, or Rhino C# or processing, let's say Maya Python or Maya MathScript or MaxScript. So this is, it basically has set up the wrapper to talk directly to core library, which is built, I don't know, C++, C++ or something. And then they package the API as some of the UI things, like undo, redo, offset, which is like a very, let's say one-on-one or required modification for geometry, I guess. And then on the UI level, we can basically bind menu, you can see here, right? Bind the menu with the APIs. So these are different point, different aspect of the bringing the applications pipeline. Okay. So actually, you know what? While you're developing your product, there's a lot of people asking like, we need to implement this one. We have a problem for this one. We want to update this one. So it's really easy to become sort of spaghetti code like this. Yeah, I mean, what I'm saying is we basically dealing with the complex system. So in order to dealing with complex system, we need to set up very simple rule, just like graph. Yeah. So actually, all the software has their own sort of, let's say, graph is like not like graph like this. It's more about like a mental structure of the application. So how they talk, what is the sort of terminal? All the commands goes to that terminal, and then that terminal is to disseminate this information to designate function to execute, and then wait the feedback from the execution, and then bounce back to the UI. I mean, this is all about like a, let's say, system, yeah. So here, this is a little more clear diagram that I want to discuss with you guys. So there's a lot of design pattern for the for software industry. So this is sort of a very generic, let's say, pattern called MVC pattern, model view controller. I mean, obviously, this is sort of a holistic, like a concept of the how we struct the application, yeah? So the interpretation or the detailed information could be a little bit different based on what you want, basically. So here, in the view, you can call this is sort of the UI layer that you can append some UI or some button or I don't know, some mouse interaction. So using the Win32 or WPF for Windows and then div for the HTML. What else we have? Maybe Swift, you know, for the iOS. This kind of UI, the API has a lot of their own sort of UI and the API for controlling the UI, let's say view. Okay, I think what it does is basically find like a received command from the surface level and then inject this command to the model to compute. Okay, this is just like a bridge between system and human. Yeah. And then we have a controller. The reason we have a controller is because this is sort of, as I said, this bridge, because we have a lot of command. Yeah, a lot of like let's say just like game. Yeah. So actually, let me share my experience. I work with other web developers. They are really straightforward because either append their menu or not. It's very clear, right? So it's really hard to make them break. But CAD system, there's a lot of edge cases, corner cases happen easily. So what if you click with the some several shortcut? What if you drag from this point into that point? What if we have some geometry inside of this rectangle? I mean, there's a lot of corner cases. So in the first place, as I joined my company, I'm a little bit harder to communicate because they try to understand CAD system as a like web environment, which is almost impossible. So what I'm saying is that there's a lot of combination that you need to control. Yeah. So in the controller level, we have a IO. Let's say you can import JSON, CSV, or PNG, which is image or some 3D geometry, like OBJ or 3ds. This is binary format. And also we have an asset, like some image or some color or theme to define the entire loops of your applications. And also we have a command, like let's say point, or so for example, we visualizing some point here, and then we can click. There should be some menu, for example, and then you can click and then drag with the point that you visualize on the map. And then based on the command, we can filter out the data and then show the different result. What if we wanted to catch a different result and want to compare at the same time? I mean, this is all about like active command things. We have a set of command. If you click one of the icon, we basically switch the active command, and then the mouse interaction or keyboard interaction, all other interactions just goes to the active command. And then the active command, we basically ask active command, what's your command right now? If it's a selection command or if it's a draw command, it behave a little bit differently based on their own sort of selected command, let's say. And then for the implementation side, what I'm trying to say is basically I'm decomposing the concern, right? So, I mean, for example, if we found some bugs, then we can predict what kind of pipeline, which area is become break, yeah, which is really good, important things for the developing your. I mean, it has nothing to do with the developing very simple application, but this kind of mentality is really important to make a little complicated or a little smart CAD system, I guess. And also in the model, we have, now we actually have like a renderer here and geometry. In the implementation part, it has a lot of like some interesting, job that we are interested in right now, like a developing point or line, or visualizing and style, yeah. And then revealing some insight by dealing with some point cloud or line intersection or whatever things happening. So even here, so the geometry object is basically could have possibly, as we did, is like mathematical object. And then based on the different renderer, it smartly switch the looks or how they render on the screen. And then it's like a snapping, sorting, or picking, or whatever geometry computation command is goes that command process or helper area. And then this helper area is directly tweak the geometry data. So what I'm saying is I'm trying to make some of, let's say, this kind of diagram here. So this is the other different perspective of the same structure. So basically, we have the external library, let's say vector or color or math. I mean, the OpenGL or WebGL, or in case that you use some of a little high-level wrapper of the graphics tool, and then they basically provide some like a boilerplate code. Yeah. So for example, Unity. Unity has a vector, right? Unity has a math, right? Even the Rhino, they have their own sort of the library. We can consider them as external libraries here. Okay. So it has no dependency. So we basically create the basic class using, let's say, like an inherence, which is the jargon in the object-oriented programming, right? Things. So we, in the base mode level, we basically declare like a very high level concept. Yeah. So for example, for the, let's say, human, we have one head and two legs and two hands, right? Just like that. It's like give us like very boilerplate as a high level. And then individual, let's say, concrete class, point, line, area, they receive, they inherit from their parent class. So we need to implement, which is sort of a rule or guideline. So individual, individual geometry has they has same sort of structure guided by the base geometry, correct? And then there should be some particular function that only belongs to that individual unique shapes, such as get length. There's no length for the point, for example, right? So for the area, we can apply like get area function, for example. We can basically append the function as you need, okay? So this is just talks about like a hierarchy and then the data flow, how we get like a mental structure. Just I'm trying to make some X-ray of this CAD software in general, okay? And then we have a renderer here. The renderer is just, as I said, there's two more, maybe three different types of renderer. One is the, let's say, static, just one-time render, that's it. And then real-time looping rendering. And then the last one is like sort of hybrid things. We can just keep render if necessary. Otherwise, we can just make it static because we don't want, use the computation expense, right? So anyhow, whenever you create the geometry is basic, automatically append to the scene. Yeah. So scene is like, let's say one like sort of a bucket. Yeah. We can consider as a list or array. So whenever you create it, automatically goes to scene, and then every render loop, the renderer visit the scene and then ask, do you have any shape or geometry that I need to render right now? And then the scene give some geometry to the renderer, and then the renderer based on, because we consider this geometries as a mathematical object. So based on their, I don't know, maybe we have some rule, maybe they have their own unique ID, and based on the ID, the renderer take care of how they look on the screen. Yeah, it's like a high level understanding. So and then again, interaction is important, right? The user can click or dragging or click some menu, right? In order to inspect geometry or inspect the data visualization on the screen. Yeah. So as I said, we receive the command and then don't tweak something directly, which is a really dangerous way. The command always need to go to active command to be processed because we have a pipeline. We need to, even if you detour a little bit, we must follow the pipeline. Otherwise, the pipeline become break, and then you couldn't find where is the breaks. Yeah, it's really dangerous. So most important thing for the software architecture, for the not architecture, software architecture. So more about like a pipeline, and then switch, and then switch the flow of data, or let's say isolate the problem, and then something like that. Yeah. So interaction actually goes to the active command, right? So active command is process who are you basically? Oh, I'm clicking event, okay? So since you use a plus shift button, I think you need to go to command process. And then the common process. And common process, well, a lot of geometry-centric like computation functions are there. So we smartly switch the function, and then internally, they directly talk or modify the geometry, yeah? And then, as I said, the renderer is independently loop, and then whenever they change, they pick up the change, and then they reflect the change for the screen as rendered. So these are sort of very high level, like a mental skeleton of the architecture for the CAD softwares. Do you guys have any question about it?